Yeah, I hope now the screen is visible.
Yes, sir. Your screen is visible.
Yes. So I can start
Can
then?
you? So,
Yes. So
here, Sovik, you can start.
yes. So thank you, Professor Dubey, and thank you for like organizing this workshop and then inviting me for presenting. And sorry for not being able to join in person. So I'm presenting it online. So today I'll talk about the current status of MSW based biomethanation plant in India and the project that we did where we visited all the plants across India, and then we tried to understand what are the challenges with this MSW based biomethanation plant in India and how we can help Indian government and the industry to make this technology more implemented in the field for energy generation. So in this project we basically wanted to see what is the scope of MSW based biomethanation. So what we did is that first of all we collected data on 1 million plus cities. If the 1 million plus cities is having any biomethanation plant entirely based on MSW, that we focused on collecting the data. We did not collect data from biomethanation plant that is based out of cow dung or based out of wastewater or wastewater sludge. So we entirely focused on MSW based biomethanation plant across India in 1 million plus cities. And when we got the data, first of all, the data is not available, and we tried to get some data. And when we got the data, we collected data from around 83 plants across 30 cities, and in that 64 plants in 23 cities we visited. Personally, I visited with my team to see what is happening in the plant. We made a questionnaire. We gave them the questionnaire. They answered based on the questions provided to them, and we got a lot of information in terms of technical inputs from the operators, the operation and maintenance, how they do, and all those things. I will discuss more on that. And the rest of the plants, around 20 plants, we got data by email, by phone call, by online meeting, because it was not possible to visit all the funds in limited amount of funds that was sanctioned for this project. But today I will speak about all the 83 plants across India. So I can show you the map the across India where we have visited and what are the status of the plants in India. So these almost this blue color legend shows the states where we visited, and we got the data. We got data from the northmost plant, that is in Himachal, in Simla, one of the smallest plant, but we got data from there as well. Then we went to south as well, to Andhra, Telangana, and Karnataka. So from there also we got data, and the red colored states are basically the states where we did not get data. Either there was no MSW based biomethylation plants operating, like Haryana and other places. There was a biomethylation plant, but they were not based on MSW. They were based on other feeds like Napier grass or wastewater sludge and all those things. So these are the basically overview of the cities and the states for which we collected data for this biomethylation project, and then we analyze the data that we got for some of the plants in Delhi, because we are based out of Delhi. We collected data. We collected samples, real samples from the leachate, from the digestate, from the waste, and then we characterize that samples as well. That I'm not going to present today because of lack of time. We'll just present overall data on the plants that we have visited across India. So while we went for this visit to different plants across India, we found these are the major biomethanation plant bed design in India. So it can be either KVIC design, so modified Khadi and Village Industries Commission design, so it's called a KVIC design. It can be modified Deen Bandhu design. It can be CFTRI design, which is mainly for the kitchen waste. It can be Bark Nisarguna design, or there is Malham's design. Malham is one of the biggest company that has biomethylation plants in India. And then we have CSIR IICT's AGR technology, anaerobic gas lift reactor, and then you have Terry's team technology. so enhanced acidification and methanation technology. So these are basically the different sets of design that we found, where we did this analysis and found the different types of biomethylation plant and the designs that were prevalent in India. Now coming to the data that we got, so if you see, majorly the plants that we have visited, we found the plants to be operational. Almost 88% of the plants were operational in India, and a small number of plants were not operational. The plants that were not operational were found to be stopped working during COVID, or just when COVID came. And what happened is that once COVID came, the waste input stopped, and slowly the reactor stopped working. And then the municipality or the ULB did not take some effort, or did not do the retendering and manage the start of the biomethylation plant, and it was shut down completely. This is the fate for the five biomethylation plant in Delhi. So actually Delhi doesn't have any biomethylation plant as of now. So the Delhi NCR has biomethylation plant, but not Delhi. So Greater Noida and other places has biomethylation plant, but not Delhi. The plants in Delhi, they were all operational before COVID, and after COVID they did not operate because of lack of waste. The manpower did not come, and then the operator, he ran over something like that. Mainly because of non-functionality, was mainly because of the lack of fund, administrative issues, the tender getting expired, and all those issues. In some cases there was public opposition as well. We have seen people complaining about this biomethane plant is a hazardous thing, because it can lead to fire. It can lead to some kind of fire hazard. So that is one of the challenges that we have seen, where we interacted with the local people staying around the biomethanation plant. Then, if you talk about the size or the capacity of the biomethanation plant, so we have seen plants less than 1 TPD. TPD means tons per day, so amount of waste they are handling per day. And 1 ton basically is 1,000 the kilo. So we have seen small plants, like the plant in Shimla, the northernmost plant we have seen. It was operated at a capacity of around 500 kilos of waste per day, 500 kilos of municipal solid waste, or the organic fraction of municipal solid waste per day. And then we have seen the biggest biomethylation plant in Asia, and also in India, the biomethylation plant in Devguradia in Indore, which is designed at a capacity of 550 tons per day. And majorly, if you see the graph, the plants were approximately having an average design capacity of 5 TPD. So 5 TPD is the sweet spot that we found, is the capacity of the biomethanation plant, where we went across all the plants in India. Mainly what we found is that if we increase the size of the plant, first of all the capital investment increases, and the ULBs are not supporting so much capital investment in some project which is basically dealing with waste. And they also need to provide more land, more space, that is not available to the ULBs, to the municipalities. So they don't go for a bigger size plan. They go for a smaller size plan. So generally we see up to 5 TPD. So 1 to 5 TPD is the sweet spot that we see for the biomethylation plant. We have some bigger plants as well. Like if I give you examples, in Pune city they have plants. They manage it in a decentralized way, and they have plans ranging from 5 to 10 TPD across various places throughout the Pune city, and in that way they manage. But generally we have seen plants in the range of 5 TPD only, not beyond that, mainly because of financial and the space requirement. And also making a centralized big plant, like Indore is doing a centralized bigger plant for the entire city. That is not always feasible in Indian countries because of space and funds. In terms of digester type, mainly we have seen three different types of digester prevalent in the biomethylation plant. Either it can be fixed type, or it can be floating type, or it can be a container type. In some of the cases we did not get any information how they have designed this biomethylation plant. So in fixed type, the dome is fixed and the dome doesn't float. or it is basically fixed to the boundaries, and whenever the gas is formed, it is just pressurized in the dome, and it goes to the purified, or basically for purification, or to the next chamber for purification or for conversion into electricity. In floating type, the dome is floating on the water, so it is sealed with water. As we generally know how the biomedicinal plant are designed. So floating type, they have major issues in terms of the gas getting leaked. So if you have too much production of gas, maybe because of temperature, maybe because of very good quality of organic waste, in that case the gas leaks out of floating time digester, and it's basically wasting your resources. So the operators, the designers, they generally moved on from your floating time type digester to fixed type digester, and hence we found that fixed type digester was more prevalent in the biomedicinal plant. In some cases we also got container type, so basically it's a cost effective solution. They have a container, and then they try to make a biomedicinal plant by just making some holes and doing some connections in terms of pipes, and that is the most efficient way to do it. But mainly we found that fixed type is the prevalent type of digester or digester available in India. In terms of stages of digestion, we generally know there are two stages which is used across Europe. Either it can be go for the thermophilic and then mesophilic, or it can be both thermophilic, or it can be both mesophilic. So in India, we also have almost both the different types of design. Slightly the two-stage digester, where the new digesters were coming with a two-stage mechanism. So in that you have either a first stage aerobic and then the anaerobic one, or you have both the anaerobic stages. Mesophilic and then again mesophilic, or thermophilic and then mesophilic, and then you also have a single state digester. So generally what we have seen is that for the single state digester, the methane yield is less. Okay, if you're going for a two stage digestion, the process is more efficient, and you get more methane yield. That is what the data we got while we did this project. And the single stage also requires less space, but two stage requires a little bit of more space, more cost, and all those things. But overall you get more methane and biogas yield. You also have two centric circle based design. It is again kind of, you have a one circle like this, and you have a other cycle like this, two tanks where inside you have a maybe a thermophilic zone, and then you have a mesophilic zone. So you are basically like combining a single stage digester, two single stage digester in one zone. So that is also was seen in some of the cases where they are doing biomethanation. Again, this kind of design saves space, but it requires a lot of management in terms of in terms of design and operation. In terms of digestion process, you have two types of digestion process. Either it can be high rate or it can be a low rate. In high rate, generally what we consider is that if you are either giving heating, if you are either heating the reactor, or you are mixing, or you are providing both, then we consider them as a high rate digester. Or if you are not doing any one of these, or both of them, we consider them as a low rate digester. So in high rate digester, as the name suggests, you have more methane yield. You will produce more methane yield because of you are providing mixing, you are providing heating. And the low rate digester are the old digesters, generally what we have seen. So the methane yield is less compared to the high rate digestion process. And in some of the cases, we were not very much sure about what was going on inside, because the operators and the person responsible, they don't know whether heating is going on inside or not, or mixing is done or not. So these are some of the challenges that we have faced, and I will discuss that in the later part. In terms of inoculum is also very important, because that is the main enzymes or main microbes that are going to work for this biodigestion process. So prevalent, it was cow dung is basically is easily available in India, because we have a lot of cows, and a lot of places where we see a lot of shades of cows. So they get cow dung very easily. So generally they use cow dung for inoculation in the biomethylation plant. But in some cases, we have seen that cow dung is also added with some bacterial culture. So they take the bacterial culture from various labs. Okay, they have some culture that can reduce your startup time. So they add cow dung, and with that they add the bacterial culture as well. And every 6 months or maybe 1 year, depending upon how quickly your reactor is getting upset, they add again cow dung and the bacterial culture regularly for proper maintenance. In some cases, we have also seen cow dung and jaggery both are used. Sometimes they use cow dung and jaggery, or sometimes they use cow dung and bacteria, or maybe jaggery and bacteria, because sometimes cow dung is not available in some places, in the plants that is in the city area. There getting cow dung is not that easy, so for that case they add jaggery. Okay, and they also add some enzymes and some bacteria from private labs. They buy it from the lab, and then they add that as well. In other cases, in few other example we have seen, they are adding sewage as well, sewage sludge as well, or the raw wastewater as well as the inoculum, because they don't have any other source. But mainly what we have seen is the cow dung is the most prevalent inoculum source for this biomethanation plant. So overall, how the biomethanation plant operates and what are the process in India, what is happening, I can show you here. We generally know what happens in a biomethanation plant, but this is what happens really in the biomethanation plant in India. So first you get the mixed household waste, basically the unsegregated municipal solid waste, where you have the plastics, the organics, and everything inside. And generally, what I have seen is that none of the cities are doing segregation, which is one of the important thing if you are applying any process in terms of uh, management of municipal solid waste. So only Indore is doing almost 90% or maybe 95% segregation, and they are following a good model in terms of implementing it with NGOs and finding the people if you are not segregating your waste in your home. So generally, if you leave aside Indore, it's an exception for India. The biomedicinal plant, they get this kind of mixed waste, and the mixed waste is first of all segregated either just before the waste is received in the biomedicinal plant. They have a segregation unit maybe just before the biomedicinal plant, or inside the biomedicinal plant campus only they get the waste, and then they do manual segregation. They segregate the organics and then they segregate the inorganics. After the segregation, the first stage of segregation, they again do some pre-processing. In the pre-processing, what they do is that they again segregate the organic waste. Like if we just if we see in the organic waste, we have sometimes plastics also, some napkins also, some wooden spoons as well, some orange peels, some other kind of metals, some other kind of fruits, like sometimes metals as well, sometimes fruits like oranges. You have coconut shells, you have coconut as well. So these all things cannot go to the biomethylation reactor, the digester. So they do some pre-processing where they remove this kind of stuff that they don't want to throw in the biomethylation reactor. Oranges and all those things are removed because it will make your reactor more acidic, which we don't want. So they will remove in the pre-processing unit. After that, they will go for the feeding of the biomethane reactor. In that case, what they do is that they crush it. Okay, they mix it, and they add water. This water can be either the recirculated water that is coming from the digester, so the recirculated amount of water that is coming out of the digester back in the first stage here, or they can use fresh water. In some cases, what we have seen is that they take hot water. They either have solar heater or a normal electric heater. They take hot water and they add it here, so that it increases the temperature of the liquid going into the digester. So basically they make a slurry out of it, and after mixing, after grinding, it becomes kind of a leachate kind of thing, kind of black slurry. And this slurry is basically collected in the leachate collection tank, and then it goes to the digester. So as I told you, this leachate that is going here, and then the some part of leachate is recirculated back in the process itself, because they maintain the amount of microbes, or they increase the retention of the microbes in the digestion, in the biomethylation process, in the digestion chamber. So, and they also decrease your consumption of fresh water, because you need some water when you are grinding this solid, or basically the organic fraction of municipal solid waste, and you're making leachate. So that is one of the advantage of recycling the leachate. And in the output, you have the slurry, the digested, that is coming out. and generally the output slurry is kept in a drying bed, and it is kept there for maybe few days generally, because it will dry, and after drying it becomes kind of a organic fertilizer which can be either discarded or it can be sold to someone, to the villagers, or maybe to the farmers. And you also have the output biogas. Generally the output biogas is collected on the top of the reactor, and in maximum cases this biogas is the unpurified biogas. They don't purify this biogas. They have this biogas diesel engine kind of thing, so kind of a DG, kind of a modified DG. So they just pump this biogas into this DG set, which converts this biogas into electricity, and this electricity is very less in amount, so they don't sell it back to the grid. They just use it for their own captive consumption, and which reduces their operating cost. Overall, the biogas is one of the main output of the biodigestion or the biomethanation process. We can also have bio CNG, but bio CNG is basically having more than 95% methane, which requires proper processing of the impure biogas that we're getting from the biomethanation plant. So you need to have some purification system installed, and then once you get bio CNG, you can put it in the cascade, or you can cascade it, you can bottle it, and you can then sell it to the industries, or to anyone who wants to use this bio CNG, or it can be converted into electricity, and then it can be given back to the grid for consumption. We also have slurry, the slurry coming out from the digested, I'm sorry, from the biomedicinal plant, from the digester, and this slurry has to be dried, and then after drying, some part of the water or the digested is recycled back, as I told you. And you also have the compost, the dried part of the compost. This slurry can also be sold, and it is sold in India as a liquid fertilizer in many places like Ahmedabad, Pune. They packet it and they sell it at a price of around 500 rupees per kg, and it is widely accepted at this price in many places in India. And in some places like in Delhi, they are not able to sell the slurry, they are not able to sell the compost, because there is no farming, and people are having a stigma attached to this kind of compost. They say that it's a waste thing, it will kill your crops and all those things, so they are not able to sell this compost. They have to just dump it in a low lying areas. So coming to the observation and recommendation that we have after this entire project, and what are the feedback we can give it to the ministry, because it was sponsored by the ministry. So first of all, we found that there is no record of design available on the site. If you go to a STP as well, the sewage treatment plant as well, or WTP as well, we at least have some. Record of design, like what is the design, HRT and all those things. But if you go to a biomedicinal plant, there is no record of what is the design of the biomedicinal plant, at what temperature it is going to be operated, at what oil and all those things. So that is not there, so we don't have any information on that. Waste segregation, as I told you, is a major challenge in India, but if this waste segregation is done, then almost these plants will be easy to operate, because there you will be removing one extra step, where you are doing the segregation and then you are going for biomethanation. And majority what we found is that if you go to the southern states, the plants are operated well, they are functional, they are operating well, they are functional, and they are able to generate good amount of methane, mainly because of the temperature in southern parts is higher compared to the northern part of India. And if you compare Delhi, in Delhi the temperature goes down to around 5-6 degrees at night in peak winter, and which is very bad for biomethane reactor. And the optimum temperature for biomethanation is around 40 degrees centigrade, so which is very close to the temperature that we see in southern states. If we talk about bio-CNG and bottling plants, in that case, they are mostly profitable, especially for the bigger ones. So if you talk about bottling the smaller plant, no, that is not a good option, because it will not make sense profitably. So generally what we found is that if you go for bigger plants, across like around 30 to 50 tons per day, in that case bottling and selling the bio CNG is profitable. We have found high smell nuisances across the plants because they store the waste in the open, so a lot of smell and fly nuisance, and especially if they have some aerobic digester, in that case the smell is again higher. So that is one challenge, and that is why some of the localities, some of the people in the localities of the biomethane plant, they want the plants to be stopped because they have a lot of smell and a lot of issues with this fly and all those things. Disposal of solid after dewatering, as I told you, the compost or the manure that is generated after you remove the solids, or sorry, remove the water from the slurry, is a challenge because there is nobody who wants to take this solid, and or nobody wants to use this solid. So the operator doesn't know what to do. They just dump it in some low-lying areas, and it is just wasted. There is no guidelines in terms of disposal of the reactors whenever it is emptied. Suppose a biomethane reactor is emptied, and the sludge, the liquid inside it has to be discarded, but there is no guidelines what the operator should do with this kind of sludge. uh, Generally what we see is that they pump all this waste, they dilute this waste and they put it in the sewers, and these and the STPs and all those things get a shock load, and that is again challenge for the STP. But that is not the way how we should manage this kind of scenarios. Then there are some problems with the ULBs as well. So what happens that suppose a company has designed the biomedicinal plant, and it operated for 5 years, and then after 5 years the tender has expired, and it goes to the new company, and the new company doesn't wants to operate at that design guidelines, or doesn't know how to operate because there is no exchange of information from the first one to the last one. So in that case the plant are all stopped. This is what happened generally during the COVID. Before COVID someone operated the plants, and after COVID someone else came. That is a challenge, and they don't know how to operate the plant. We had discussion with plant operator, and they told us getting segregated waste is a challenge. That is what we generally found out. And then selling the outputs, the slurry, the compost, the biogas is a major challenge. They cannot sell the output is basically slurry, compost, and biogas. And as I told you, we found that if the plants are having capacity more than 30 tons per day, then it makes economically sense to bottle your biogas or bio CNG and then sell it, or produce electricity and then you put it back to the grid, and by net metering. That is basically advantageous for the plants operator, that they sell back the bio CNG or electricity generated by this waste. Then there are resistance by the general public that we found while construction. Many plants were stopped during construction phase, and some of them were stopped during operation phase because they thought that the balloons where the gases will be stored are hazardous, and they can leak sometime, and they can create fire nuisance and all those things. Smell and gas leakage are some of the challenges that they anticipate. So they stopped all those operation and all the construction of this kind of plant. In I think in Pune, I remember visiting a plant which was just built beside a power grid, and it was something I was shocked to see that biomethane plant with so much amount of biogas, big digester, big balloons just be built beside a grid station where they're supplying electricity for the entire city. It is basically very hazardous and prone to any kind of hazard. Then the plants needed some external financial support. There is no incentive for the operators to manage waste, to segregate the waste, to collect the waste, and then produce revenue or produce biogas. So they need some incentives. They need some financial support from the ULBs, from the municipality. That is what we found. And because they are doing segregation, then they are doing managing the biomedical process as well. So they need some amount of financial support. Overall, this project was funded by CPHO. So we gave some recommendation to CPHO. I don't know how much active they will be to implement our recommendation and to take it forward. But we gave them some recommendations. Some of them are highlighted here, like keeping a record of the design of parameters. Like when we go to STP or WTP, we know these are the design parameters, these are the inlet parameters, these are the outlet parameters, but nothing like that is present currently in any BMP biomethanation plant across India. So we told that at least you should have some basic design guidelines like OLR, SRT, reactor volume, your feed inlet, your water content, and all those things, at least in the plant itself. Measuring the key parameters like amount of gas getting generated, amount of moisture that is for which it is designed, and all those things. Then there is no or very less negligible productive measures for the biogas storage balloons. We have seen the balloons getting leaked or getting stolen from the sites, and that is one of the challenges. So we told them to have proper protective measures to implement that in the field. Also to record the amount of liquid slurry, the amount of solid compost that they are producing, because if we can measure, if you have the data, then we can see the data, and we can then see, we can look into that, and we can suggest more changes to the process as well. And gas uses norms for the smaller plants is not present, because if they are not doing bottling, what you will do? In many cases we have seen that they produce biogas and then they just flare it. So that is not a very good option, the flaring the biogas. But some of the smaller plants, because they're not able to bottle it and they don't know what to do, there is no direction available, they just flare the biogas. That is not very good. And electricity from biogas should be taken under the umbrella of renewable and alternate energy. And I think in that respect some of the work has been already started, so they should consider this as a renewable source of energy and take it forward. In terms of captive consumption, wherever possible, they should encourage captive consumption without giving it back to the grid. In some cases they do captive consumption, the operators. In some cases they are not allowed to do captive consumption, they have to give it back to the ULBs. And the ULB should also take into account some NGOs and spread the awareness in the common people, should to tell that these plants are not there, or not going to harm you. They are good for the society, because they are managing your waste, and you should allow these plants to be operated. I have seen many examples where the plants were operated, but there was some complaint from the local public, and the plant stopped, and now the waste is just lying around in the campus or in the streets. So these are challenges that we have faced, and we have given some recommendation based on our input. And overall, I think I have come to the end of my PPT, and this is the team that we did the survey, and almost all of them have graduated and they have completed their PhD. And Professor Nema was the main PI who helped us in carrying out this project. And I visited almost all the plants with these students, and to see what are the challenges with this plan, and then we got the data. And overall, this is my group, and I'd like to thank my group for helping me in carrying out this research. And my department of civil environmental engineering at IIT Delhi, and environmental engineering group at civil environmental engineering at IIT Delhi. And lastly, I would like to thank the funding agency CPHO under MOHUA, which funded this project. And if you have any questions, I think I can answer. Thank you.
Discussion on biomethanation plants, we can have a few quick questions from audience.
Shavik,
Any
yeah,
questions?
Dr. Shavik,
Yes, yes.
yeah, you should be here. IIT Kharagpur is your Elma Institute.
Sorry for not being able to join, sir. I am currently in Kerala giving one more talk. So I
Well,
regret
thank
it.
you. I think the information you have shared, I think we really enjoyed what information you shared. Uh, I think, see, when you recommended, I think some recommendation, you didn't talk on anything onto that technology because, like this KVIC and the Deen Bandhu, they become absolute technology nowadays. Mostly people are going for either CSTR, even this what CSIR, that technology also I think many places is not working. So because I didn't find any recommendation on the that technology part, like the digester need to be changed or something like that. So what is your this?
Sir, in the detailed project report, we have given the guidelines of how to design a biomethylation plant. Like we have our CPHO manual for WTP and STP. Similarly, we have given a detailed design on how do you design the biomethylation plant. We have not told that this kind of design is bad or this type of design is good, but we have given our own design in terms of the OLR, SLR, organic loading rate, amount, methane yield, and all those things. So we have made a comprehensive design. We have made a Excel sheet on that as well. So if you put the values on the waste, and it will give you complete design of amount of the design guidelines. So that is already there in our report.
Thank you, sure.
Thank you, sir.
Yeah, Dr. Sovik, just wanted to know that you have shown that 83 plants you received the data online, 64 site visit has been done. So, have you done any analysis of these two separately, the data which you have received online and the one which you visited?
No, actually, the total data is for 83 plants, out of which I think around 19 we got it online. The rest we visited. So total is
Okay,
the total project is for 83, around 83 plants.
okay, so that analysis contains the data which has been received online also.
Yes, yes, yes. So if you see, all the graphs were having two kind of bars. So one was where we visited, and other was the total value, considering
Okay,
the not visited one and the visited one as well.
okay, thank you.
Thank you.
Any more questions? Okay, then thank you so much for taking out time and joining us. Okay, we have one more question.
Hi, Sovik. I happen to be at this Nasik plant, uh, this biomethanization plant. So one of the major challenge we faced over there regarding the getting of the food waste was also the piggery diversion, piggeries diversion, if I can say. So I think for biomethanization plant in India at any places, this is a menace. So I guess when we say that we are unable to get the segregated food waste, it is not only the mixed nature of the food waste that is generated at the source, but also a major chunk of it gets diverted to the piggeries ecosystem, which again is having a value in which the generators find that it is revenue wise good for me to give to them rather than give to the municipalities, and then it goes to the plant. I think that factor in also could be brought on a larger sphere percentage basis to be put forward to wherever if the report is to be generated.
Yeah, I agree
Just
with.
as a,
Yeah, I agree with you. And this we have already given to CPHO in our detailed report. Because of lack of time, I cannot cover all the recommendation. But we have given that, like, there is one way where the mainly the hotels, they give their waste to the piggeries because they charge very, or they basically pay them. But that is not the proper way to manage our organic fraction of municipal solid waste. So instead of that, if you will be mandates that you have to give it to a biomethanation operator, not to the piggery, so then that will be stopped, and then it can be used for biogas digestion. So that is already covered in our one of the recommendation.
Okay, so thank you very much, sir, for taking out time and being part of this workshop. So moving on to our next presentation, we have our next speaker joining us online, Professor Dilip Khativara. Professor Dilip,